Now let's look at significance tests for the difference of means. So your null hypothesis is always that there is no difference between the two. So you can look at it as mu sub 1 minus mu sub 2 equals 0, or that mu sub 1 equals mu sub 2. They both mean the same thing, so just be prepared to see them in either format. For your conditions, it's the same as what we dealt with confidence intervals. So, has the mean number of hours Americans work in a week changed? One of the questions on the General Social Survey asked respondents how many hours they work each week. Responses from random samples of employed Americans were recorded for 1975 and 2014. They are summarized here. Do these data give convincing evidence at the alpha is 0.05 significance level of a difference in the true mean number of work hours per week for Americans in 1975 and 2014? So state the appropriate hypotheses for performing a significance test. Be sure to define the parameters of interest. And then check if the conditions for performing the test are met. So our null hypothesis is that the difference would be 0, or that they are equal to each other. And our alternative is going to be that they are not equal to one another, or that their difference is not equal to 0. Then we need to define the parameters that we've noted. So one needs to be the true mean hours worked in 1975, and the other in 2014. Do notice that in their hypotheses, they use the years as their subscripts, but when they're defining the parameters, they've used something different. This is not okay. This is an error. Please make sure you're being consistent with your notation. Alright, so we did have random samples of 764 working Americans in 1975 and 1,501 working in 2014. Those definitely are less than 10% of all working Americans within those during those 2 years, and both have large samples. So now we're on to the actual test, doing your standardized test statistic. So again, on your formula sheet, you have standardized test statistic equals statistic minus parameter divided by standard deviation of a statistic. So you always have to fill in the appropriate information. So your statistic, again, is the difference of the means from the samples, and then your standard deviation of the statistic is that standard error. So again, you can do this with a calculator, or you can do it by hand. And again, degrees of freedom by hand comes from the smaller group, but by technology, you'll get something completely different. So explain why the sample results give some evidence for the alternative, that there is a difference. Calculate the standardized test statistic and p-value, and then what conclusion would you make using the alpha as 0.05? Well, in the observed data here, there is a difference in their mean hours worked, which gives evidence for the alternative. So calculating the test statistic, putting in the difference of the means, the hypothesized value, that there is no difference, and then filling in for our standard error, we get a test statistic of 4.88. So, using your table, your degrees of freedom would be 100. You're looking at the smallest sample, subtracting 1, 763. So on the table, the largest number that is less than 763 is 100. And when you go over, you're going to get a p-value of less than 0.005. But again, this is a not equal to, that means two-tailed test, so we need to multiply by 2. So we get a p-value less than 0.001. If you are using your calculator, you're using the two-sample t-test, which gives us a p-value of 0.0000115, and degrees of freedom 1,660.58. Both of these are yielding a p-value that's essentially 0. So because the p-value of essentially 0 is less than alpha 0.05, we reject H0. There is convincing evidence of a difference in the true mean hours worked by Americans in 1975 and 2014. So this is just some summary of everything that we've just talked about with hypothesis testing. In this example, though, you actually are given the data set and not the statistics. So here you would actually have to calculate the mean and the standard deviation of each group in order to fill in the information for the hypothesis test. So you'd set up your hypotheses, define your parameters, and list your significance level just like normal. These are both small groups, so you would have to graph the data. And then this is where you would have to use your calculator to actually calculate the mean and the standard deviation of each sample. If you're using your calculator and you do the two-sample t-test, instead of using the statistic option, you would use the data option. You would fill in the data on the table and then go back and do a two-sample t-test based on that data. So, the formula for two-sample t-statistic for a test about the difference in mean often leads to calculation errors by students. Also, the p-value from technology is smaller and more accurate than the one obtained using the conservative method. As a result, your teacher may recommend using the calculator's two-sample t feature to perform calculations. Remember, if you're using your calculator, you must name the test, give the test statistic value, the p-value, and the degrees of freedom. We talked about pooled when we were doing proportions, but we're not using pooled whenever we're doing averages. It is only for doing proportions on a significance test.